So what we have is, forget about this, guys. What I want to do is, why do we, when we have an equation, why do we only multiply the top instead of multiplying the top and the bottoms when we're trying to produce equivalent equations? So let's go ahead and look at two things. Let's say I have a fraction. And then let's say I do 1/2 plus 2/3 equals 1. Okay. Then let's look at this case where I want to solve, and I have 1/4 plus 2/5 x equals 3/20. OK? Now, here, I'm sorry, we don't know that equals 1. Here, I'm trying to add two equations, or I'm trying to add two fractions, right? So to add two fractions, they have to have common denominators, right? They have to have common denominators. So to get common denominators, we multiply by an LCM, which is going to be, our LCM in this case is 6. So in this case, what I'm going to do is I'm going to take 1/2 plus 2/3 equals. Now, we don't know what it equals yet, right? But we'll multiply each side by 2/2. Here, I multiply by 3/3. So therefore, what I get is an equivalent fractions. Because 3/6, is that equivalent to 1/2? Yes. Is 4/6 equivalent to 2/3? Yes. Right? So the only reason why I'm going to use equivalent fractions is so that I can combine them. Because now I can combine these two. Does that make sense? Because now they have the same denominator. All right. Now, in an equation, we're not trying to combine. Now, you could combine. If you wanted to combine these two to get them to be the LCM, you could combine these to both have a denominator of 20, and then you could add them. But there's a problem. This one's an x, right? So we're not trying to combine anything. What we're trying to do here is when I'm trying to eliminate, my denominator, if I multiply everything times my LCM, here my LCM is equal to 20. If I multiply everything times 20, what you'll have now is that becomes 5, 4, and that becomes 1. Now what you have is 5 plus 8x equals 3. So now what you have in this case is an equivalent equation. 5x plus 8x equals 3 is the exact same as 1/4 plus 2/5 x equals 3/2. It just depends on what you're trying to do. Are you going to multiply to give equivalent equations or equivalent fractions? Now, in your case, what if I multiply the top and bottom by 20? What if we did that? Rather than multiplying just by 20, we multiply the top and bottom by 20. Well, then we'd have 20 over 80 plus 40 over 100 x equals 20 over 20, so 20, 20. And this would be 60 over 400. Now, did multiplying it by 20 over 20 produce us an equation that's easier to solve for? No, they all still have different denominators, right? But what multiplying by 20 over 20 did do is it just produced us another equivalent equation. So it didn't change anything. You just created something that's equal to our original equation. But if I just multiply by the LCM, it still produces an equivalent equation, but it produces an equivalent equation that does not have fractions. Does that kind of make a little sense? So there is a big difference on why we multiply by our LCM to get rid of the fractions and why we multiply by our LCM to get equivalent equations or equivalent terms. So if you want to just get something equivalent, i.e. to add or subtract fractions, multiply by your LCM over your LCM. If you want to do something to get rid of your denominator, just multiply by the LCM. OK? That is a brief little overview. Did that answer that question at all?